Folks, I'm Rishikesh, a product security engineer. Today I'll walk you through VulnReach, which is a tool focused on reachability-based vulnerability analysis. The core problem today here is SCA scanners creates a huge volume of CVEs, most of which are not actually exploitable. This creates alert fatigues and slows down remediation, which in turns is actually a waste of engineering efforts. The real question is this vulnerable code or package being actually called at my runtime or is actually reachable, right? So this is where VulnReach comes in. It bridges the gap between detection and reachability. Okay, when we say reachability, we classify it into static and dynamic. So for static analysis, we look at import analysis, we look at taint analysis, we look at AST graphs, we look at the data flow graphs that happens between different files that are inter-procedure calls. Along with static analysis, VulnReach also introduces runtime validation, that is dynamic analysis using probes, hooks, and execution traces. Okay. So we have end-to-end runtime validation for Python projects, which actually, injects coverage schema into your Docker files, and then whenever the app is up and you have some traffic to it, the coverage actually covers all the files and all the hooks that are being triggered when the app is in runtime. And whenever your scanning is done, completed, this coverage is sent back to the engine and where it gets correlated and you actually know which package was actually invoked when there was an actual traffic that was created. So let me quickly take you to the GitHub repo where all this code is open sourced. You can use it uh, as well as you can make contributions to the project. I'll quickly share the screen and I'll show you how the deployment works. So this is the entire source code of VulnReach. I'll quickly take you to how it works. Uh, so this is how it works, right? We require scanner data. For example, now we currently Trivy has been integrated as a tool. So second stage is where we do the taint analysis. So we use tainter. This is a Python package that is also written by me. It does taint analysis between files on an entire directory or on a single file. So uh, all kind of taint source and sink analysis is you can do with tainter. Third is the AST analysis, which helps you to see the call graph of the function. Fourth is the route exposure. We try to fetch all the HTTP endpoints and HTTP routes from the project. Last is the runtime coverage, where we actually see if the code is actually being exploitable. So for the runtime coverage, we have a Docker network. We have the container that comes up, and we have schema thesis in place wherein we generate a traffic that actually, hits to the app between this network, and we see the coverage. The coverage thing that we injected into the Docker file actually, hooks all this coverage and will give you the uh, result on the UI. So when we talk about when the tire is dynamically reachable, this means the runtime coverage was confirmed and confirmed after execution. So you have to fix that immediately. So it's like a critical thing uh, for a DevOps or a developer to actually fix the package. Statically reachable is when you see import functions, you see call graphs, you see uh, if that specific package is being called at a function and if that function is actually being called at in some other file. So this actually proves that the code path is existing and we have a high priority for that packages. Not reachable and uncertain are those packages which comes under transient sometimes, or which are actually a part of your package but are not actually used in your entire source code. So this is how you can have a quick start at the of our OneRich for the project. So we have a .env example file, which is actually the variables that are required when you boot up VulnReach. So the quick thing that I would like to call out is how do you actually want to start VulnReach, right? If you just want to look at the static analysis part, you can just use Docker Compose build, right? Which will actually create an instance on your machine, on your network, and it's just good to, onboard your repos. But when you talk about uh, looking at the runtime scans, this is the command where we actually have a runtime Docker Compose file, which actually helps to create that network that we talked earlier about, which has this network, your OneRich instance. Along with that instance, you have your app. So the connectivity between all this are required. We also have an open API collection for this. So if you don't want to, uh, you know, have it on your you don't if you don't want to use it like SaaS, you can have it via the Postman option as well. So I already have it cloned and running. I'll just switch to it. Yeah. So this is how OneRich looks like. So let me log in. Yeah. So this is our candidate for today. That is multi-tier DVPA. It's also hosted on my GitHub. So if you see here, we have around 11 packages, 2 critical, 5 high, 3 medium. As I open this, this is the findings, wherein the backend is Django, and we were using a Django vulnerable package. So you can see here are those call paths that were actually triggered. This is the evidence sink. These are the files in which those imports are there. Along with this, you can just scroll and see the number of CVEs. So this is the upgrade pattern, the upgrade versions that you can, put it. So PyJot, cryptography, all these are high and dynamically reachable. If I scroll down, you can see Pillow. So Pillow would not be triggered by any of the endpoints, so it's statically reachable. So there's one unknown package which was not resolved, so we don't have any evidence for it. So we focus on giving correlation based on true metrics, which actually classifies dynamic, static, and not reachable. We have fixed plan wherein you actually see the priority orders for the packages to be fixed. Alongside, we have this raw JSON, which actually is the entire tool's output, wherein you see specific package Django is affected by a lot of CVEs. The severity version and fixed versions, you can choose the latest out of this list and fix that. So we have this inventory wherein you see all the projects that are already onboarded. You can export it from here. To create a new scan, just enter your GitHub repo and the main thing, that is the scan config file. I'll talk about it in some time. So just add it here, launch, and it will start a new scan. As you see, scan started 2 seconds ago. It is started running. You can see the live polling here as well. Meanwhile, the scan finishes, we'll look at the API access. Can create a API key out of it. Just give a key name, set your expiry, and create it. So the config file which we were earlier talking about is this. So if you have vulnrich.yaml already in your repository, this will the tool will actually fetch it from there. If not, you can give a generic which will override the vulnrich.yaml that exists on your repo. So you can set static reachability as true and add all these tools which are necessary. Git to clone it, Trivy to do a SCA scan out of it, Tainter to do taint analysis. Python reachability could be replaced by multi-reachability, let me share it with you 1 second. By multi-language analyzer, I'll just show you that as well. Metadata, route extractor, and dynamic reachability are for the runtime detections. So for runtime, you give enabled as a true timeout, coverage weight, and container port so that the host, the VulnReach platform, scanner, and the network knows the vulnerable app is hosted on port 3000. We have set eBPF as false since it is an experimental phase. So for runtime to work properly, you need two things. One is Docker file, and another is the Open API collection. So if it is not there, and you have an option of connecting your any LLM, and by connecting that you can create an Open API out of that. So you just have to turn this false to true and give your provider. So let's look at the scan. The scan was completed 2 minutes ago, and this is statically reachable just because we used a YAML which had runtime as false. So this is the YAML that we were talking about, multi-tier scan.yaml. So the runtime did not trigger because it shows enabled equals to false. So that means your dynamic reachability won't be triggered unless this YAML states that. This is the generic scan.yaml which you can use for your project. So it has to be with the naming convention that is vulnreach.yaml. If it is there in your repo, you do not have to give it explicitly. So if you can see, here are the tools, same as Git, Trivy, Tainter. Multi-language reachability helps you to detect different types of languages and do static analysis on those. Rest all remains same, where you see runtime is true, eBPF is false since it's in experimental mode. OpenAPI generator is also false because that repo already has the OpenAPI JSON. So this is all about VulnReach. Uh, I'm open to contributions. If you feel this project needs some enhancements, improvements, corrections, you feel free to create a PR and then we can get it. Thanks.